Okay, so this video is going to be the next in my series looking at differentiation. Guiding you through the structure of this video, essentially we're going to be looking at using your gradient function. So part one of this video, we're going to be looking at using your gradient function to work out the gradient at any point along a curve. Part two, we're going to be extending that concept to looking at how you would work out the equation of a tangent to a function. And then part three, we're going to be, it's very similar, essentially adding one more step and looking at how you'd work out the equation of a normal to a curve. So part one, going to be looking at this question here. So we want to work out the gradient of this curve, y equals 2x cubed minus 7x plus 6 when x equals 1. So your first step, you need to work out your first derivative, your gradient function. So I'm just going to differentiate this function here with respect to x. So the 2x cubed, remember I'm going to differentiate each of these terms term by term. Differentiate this first one, bring that 3 to the front, combines with that 2, gives me a 6x, decrease that power by 1, 6x squared. Second term here, minus 7x. You know that when you have a linear term like this, you differentiate it, all you do is take that coefficient there. And then that plus 6 is a constant term. Constant term has no gradient. Easiest thing to do when you're differentiating a constant term like that, it just disappears. Okay, so plus 6 plus 2 over 3 minus 7 over 3. For differentiating a term like that, it's just going to disappear. So now, I found out my first derivative, dy by dx. I need to work out the gradient when x equals 1. All I'm going to do very simply is plug in my x value into my gradient function. So when x equals 1, dy by dx equals 6. My x value goes in place of my x here in my gradient function. Bing bang bosh, very simple. So I've got 6 times by 1, which gives me 6 minus 7. Final answer, gradient when x equals 1 is going to be minus 1. No real dramas there, very straightforward. Okay, so working out the equation of a tangent to a curve. If I have this curve here, say the question asked me to find out the equation of the tangent of the curve when x equals 3, say. So this could be when x equals 3. And essentially what you're doing is if I have a straight line tangential to that curve, we're working out the equation of that straight line there. So the curve that we're going to be looking at is this one, y equals 2x cubed minus 7x plus 6. Okay, and when x equals 1, and we want to work out the equation of the tangent to this curve when x equals 1. So in the last bit of this question, or sorry, in the last bit of this video, we've actually completed one of the steps required. So you know that when you're working out the equation of a line, you're going to be using this formula here, or alternatively the y equals mx plus c formula, depending on how you've looked at this in class. But to use this formula, you need a few bits of information. So you need your gradient, okay, and we've worked that out in the previous bit of the question through differentiation. And you need the x and y coordinates of a point on this line. So we need our y coordinate, we need our x coordinate. We already have our x coordinate, which is there. So essentially, once we've worked out the gradient, which we did in the previous bit of this question, all we need now is the y coordinate. So let's just go through step by step. So first of all, we've got our x coordinate, we need our y coordinate. So when x equals 1, all we're going to do is plug in our x coordinate into this original equation here to give us the subsequent y value. Okay, so just replacing our x in this original equation with 1 here. Okay, so 2, lots of 1 gives me 2 minus 7, so lots of 1 plus 6. Okay, so 2 minus 7 minus 5 plus 6 gives me 1. So when x equals 1, y also equals 1. So I now have my y coordinate, my x coordinate. Just for completeness, I'll write this out again. So dy by dx. Now we're working out our gradients. So last bit of information in the puzzle, if you like. Dy by dx, I'm going to differentiate this. Combine my 3 with my 2, bring that power to the front, gives me 6x squared minus 7 Okay, differentiating that term just gives me -7. Differentiating this term, your +6 will disappear. So when x equals 1, your gradient, dy by dx equals 6 lots of 1 minus 7 which equals -1. And that's what we found out previously. So here we have x equal to 1, y equal to 1, a gradient equal to -1. All we're going to do is substitute this into our y minus y1 formula. Let's just separate this out. Okay, we've got everything we need to use this formula now. So I've got y minus our y1, which is 1 equals m. In this case, -1, x minus 1 in this case. So you just notice my final answer, I'm going to have a y and an x. I want the equation of a straight line. So it should be in the form y equals mx plus c if possible. So y minus 1, I'm just going to expand those brackets. We've got minus x plus 1. Tidying up, y equals minus x. Okay, I'm just going to bring this -1 over to the other side such that I've made y the subject, and this is in the form y equals mx plus c. So y equals minus x plus 2. That is the equation. That is your final answer. It's in the form y equals mx plus c, and this gives you the equation of the line that is tangential to this curve here when x equals 1. Working out the normal to a curve now, and the first thing to note is that your normal will actually be perpendicular to the tangent of a curve. So take the example we've got here. We've got y equals 2x squared plus x minus 7. So it's going to be a positive quadratic. It's going to look something like that. Obviously, I'm not going to draw it too accurately. At x equals -1, so I don't know, say x equals -1 looks about there. So if you're considering the tangent to the curve, it's clearly going to look something like this. Excuse my juddery hand. Whereas the normal to the curve is going to be perpendicular to that line. And it's going to be looks something like this. Okay, and essentially what we're doing in this question is working out the equation of this line here, the normal to the curve. So if you look at this line here, roughly speaking, what we're expecting is for the gradient to be in the region of kind of between 1.5, 2 maybe, and the y-axis intercept to be around, I don't know, say -5. So the steps are going to be exactly the same as working out the equation of the tangent, but we have one additional step, and that step is working out the perpendicular gradient. So just remember, the equation that we're working with here is your y minus y1 equals mx minus x1 equation, and we need, for this to work, we need the y coordinates, we need the x coordinate of a point on that line, and we need our gradient. So let's work with our gradient first. Just remember, this whole topic is to do with differentiation, using your gradient function to work out gradients. So I'm going to differentiate this function here, bring this 2 to the front, combines with the other 2, gives me 4x, decreasing my 2 here by 1 to give me a power of 1 up here. Don't need to write that there. Plus x, coefficient of my x there is plus 1, and you know this term here disappears. So dy by dx equals 4x plus 1. And at the point in question, i.e. when x equals -1, okay, our dy by dx is going to equal 4. I'm just going to substitute my -1 value in place of my x here. Plus 1, which equals -4 plus 1, which equals -3, excuse me. So that's the gradient of the tangent to this curve at x equals -1. We now need the perpendicular gradient to this, the gradient of the normal. So gradient of the normal, which is what's going to go in this formula here in place of our m, gradient of the normal is just going to be the negative reciprocal, i.e. I'm going to do -1 over our gradient here, which is -3. Obviously, if this gradient here came out as 4, instead of having my -3 at the bottom here, I'd have a 4 at the bottom. So always going to be the negative reciprocal. -1 over -3 is going to give me a gradient of just positive a third. Okay, so my diagram that I sketched initially was perhaps a little inaccurate, but this is the actual gradient, gradient of a third. So we have the gradient now. We need our, we've got our x-coordinate of a point on the line, which is x equals -1. We now need the y-coordinate, and very similar to, or exactly the same as when we're working out the y-coordinate for the tangent to a curve. What we're going to do is substitute in this value here, x equals -1, into our original function there. X equals -1 implies that y equals 2 lots of -1, so just replacing my x in this original equation with -1 there. Okay, working through, got 2 lots of 1, -1, -7, which gives me -1, sorry, +1, -7, gives me -6 there. So working through, we now have our x-coordinate up here, our gradient of the normal here, which is our m, and our y-coordinate, which we've just worked out. Substituting this all in, y minus -6, so y plus 6 equals our gradient 1/3 x minus -1 or x plus 1. Okay, and then just rearranging this in the form y equals mx plus c, it's always good practice to do that. Expand those brackets out, 1/3 x plus 1/3, and moving that plus 6 over to the other side, so subtracting 6 from both sides, I've got plus 1/3 minus 6, or just expressing that 6 as a fraction over 3, minus 18 over 3. So final answer, 1/3 x minus 17 over 3, and that is your final answer in the form y equals mx plus c for the normal of this curve when x equals -1. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.